Hey guys, in this short video I just want to share with you a little piece of advice, what you can do in certain situations when your design is not that perfect. I'll take as an example a sheet metal part like this one, and actually here there is a little issue with the design. This issue is located somewhere near this bend. So you see the flange is not perfect, like the bend doesn't make its way to the extremity of the flange, so here we have a little bit of a defect. It's not that serious actually, because the design is still okay, and this part can be kind of feature recognized and unfolded. So this is the feature recognized part, this is the unfolded flat pattern. Issues begin when we actually want to simulate the bending process. So if I want to simulate the bending process, then I switch to the mesh representation of the same part, and because the mesh representation is derived from the BREP representation, from the boundary representation, we do have this little spike over here as well, and it will become problematic quite soon. So if I try to simulate the bending process, then everything goes smoothly. Up to this point, there I start to unfold the last bend. So here what happens is that the part starts to intersect itself, because this spike here touches the flange next to it, and the software highlights the corresponding triangles, saying okay, there is an issue over here. So what we can do to prevent this false positive, we can come back to the original part and fix it a little bit. So we do not have to come back to the originating system for such tiny fixes. Although if you want, you can open this file in a system like Fusion, for example, and apply a push-pull operation. Luckily we have this little face that we can push-pull inside the material. So here I can do the same. I can basically use this push-pull function over here. And what this function does, it actually does a very simple thing. It takes the base face, what I just selected, it builds a prism with this highlighted face as a base face and the height of 0.3 in this case. And because I use a negative number, then instead of extending the prism in the positive direction, it takes the negative direction with respect to the material orientation. And the prism will be something like this. And this prism will be subtracted with the Boolean operation from the rest of the part. So you just need to be sure that the height is not too large, because otherwise you will also affect the rest of the part, which is unlikely something you want to do. So I just did that, so a little spike remained here. So probably this value was not perfect, and I should use something like this. Yeah, now it's much better. So this part can now be simulated without any issues. I can repeat the simulation, and then you see that there is no this spike anymore. This is a little trick that we basically published 5 years ago or something, and from the day one it was more of an experiment, and it was initially prototyped in university during one of our workshops. But surprisingly it appeared that this simple function of prism extrusion and Boolean subtraction or union, it's basically very useful to fix issues like that. So you can just go and fix your model without, turning back to the originating CAD system. So this is pretty handy, and that's why I wanted to share it with you. See you next time.